right, so welcome to my talk about JUnit 5 extensions. My name is Marc. I work for Gradle. I recently joined Gradle. Not so recently, I became a JUnit maintainer. So I did my first contribution in 2012 and kind of did a release. And rather sooner than later, I was a committer, and now I'm the team lead for both the JUnit 4 and JUnit 5 teams. I'm from Germany, so if you have questions, feel free to ask at any time, but please do it in English or in German. All right, so the good news is JUnit 5 is finally here. We started it in 2015 with a crowdfunding campaign and finally released it after 2 years of work last September. That was a 5.1 release in February, and 5.2 was just recently released end of April. And we'll try to keep up this pace and do a minor release every few months and introduce new features as we go. Okay, before I continue, I would like to do a quick show of hands, because this talk assumes that you have you're familiar with JUnit, of course, but also have seen JUnit 5 maybe already. So maybe, can you guys please raise your hands if you have written a JUnit 4 test before? Okay, JUnit 5? A couple, okay. So there's one more, good. I'm not gonna do a gentle introduction to JUnit 5 in general. I'm just gonna give you like the very brief introduction of what it is and what the big picture in terms of the architecture looks like. So that's this picture. JUnit 5 is actually not one artifact, one thing. It's comprised of the platform, Vintage, and Jupyter. So the platform is something that we built to be usable by IDEs and build tools. You want to run your tests and get some reporting out of them. Obviously, that's the platform. It does not have any idea about any testing framework. So it doesn't know JUnit 4, it does not know Jupyter, it does not know any third-party framework. But it provides an API for frameworks to register at runtime. And the JUnit 5 team has written 2 test engines, as those are called. So there's a Vintage engine that allows you to run your JUnit 3 and JUnit 4 tests on the new platform. But there's also a new engine that's called Jupyter, and that's what we're gonna focus on today. So Jupyter is actually 2 parts. There's the JUnit Jupyter API, which is what you need to write tests, like the test annotation is in there, for example. And at runtime, you also need the Jupyter engine to be able to discover and execute your tests. And all that builds upon the platform. So JUnit Jupyter API is 2 things. It's the programming model for test authors. As I said, like the test annotation and all the other annotations, assertions are in there. But it's also the extension model for extension authors, which is going to be our main focus for today. How can I write extensions for JUnit Jupyter? So the programming model, when I talk about that, pretty simple. We have a package org.JUnit Jupyter API. This is where all the annotations are in. And there's an assertions class, like assert equals. You can use a static import to get that. And then you can write your test pretty much like you used to do in JUnit 4. Just the annotations come from a different place. You might note some differences, like not everything has to be public anymore. There's a display name annotation, which is new. And there are some other new features. So I would encourage you to check them out. But I cannot cover all of them in this talk. The extension model is, okay, how can I write an extension? And this is in the extension subpackage. And it basically consists of a number of interfaces that you can implement in an extension. So in this example, we implement a before each callback and an after each callback, which each has 1 method, before each and after each. And this allows you to put some common setup teardown code, for example, into an extension that you can reuse in your tests or even in different projects. And of course, there needs to be some way to register these extensions, right? I mean, just writing extensions and tests doesn't help much. So how do you actually register them? There's actually 3 ways. So there's a declarative way, which is the first one that we introduced. So we can put the extend with annotation on a class or a method, and that will just register your extension. Similarly, you can use a field of your test class and annotate it with register extension, and that will then allow also register the extension for all the tests in this test class. There's a third way, which is using the service loader mechanism in Java. So it's actually possible, without touching any tests, to register an extension for all your tests. And very important is you can register as many extensions as you want at the same time. So it's not as in JUnit 4, where you had only one runner, and that was it. This is really designed to be combined and to be used with many extensions simultaneously. All right, and this is how it looks. So you can, for example, annotate your class with extend with. You can have a field and register it as an extension. You can also do it on the method level. And you can have multiple extensions in that extend with annotation, or you could repeat the extend with annotation multiple times. So for the remainder of this talk, I'm going to walk you through some real-life examples. I mean, they're not production-ready necessarily, but they address problems you might have in your daily testing. Not necessarily strictly unit testing, but if you do some integration testing, also using JUnit, you will find these patterns quite often. That was too fast. Okay, so before I start, all the code examples are in GitHub, so you can check them out at your leisure, right? I'm not gonna read every line of code to you. I'm not gonna explain every line of code to you. So I'm just gonna give you the big picture. Of course, if you have questions and something is really totally weird, then please ask by all means. But I'm just gonna give you like the big picture. All right. So, is this big enough in the back? Yeah? Okay. So we have a test here. Actually, we have two tests. We have an add test and a subtract test. Both have the test annotation on them. And I have this little annotation here enabled for environment. So imagine you're developing some server application. You often have some staging. So for example, you have a dev environment where every commit gets deployed to, or you have a QA environment maybe, or a pre-production environment and a production environment. And you maintain this test suite that you can check that actually everything is working. Maybe there are smoke tests. Maybe you have a really comprehensive test suite. That's not really interesting for right now. But what you might want to do is you want to have some tests that you only want to execute on certain stages. For example, they mess up some data potentially, and you don't want to do this on a production database, stuff like this. So the scenario here is we will only want to run this test on the dev and QA stage. So I have created a launch config. I can run that. And as you will see, right now, it's executed everywhere because I have passed this system property environment. That's my way to tell JUnit or tell this extension really to which environment are we running against and should this run. If I run this against a different environment, for example, let's see, prod, the add test will be disabled because it says disabled for the active environment production, right? So how does this work? This is not built into JUnit. So let's look at the implementation. The annotation is really defined locally here. You can see that from the package. It's just an annotation. It's retention runtime, target method, but it's annotated with a JUnit Jupyter annotation itself. So it's kind of a composed annotation. And that's actually a feature that you can use with all Jupyter annotations. You can use them as meta annotations and compose your own annotation. And this essentially is the same as if you would have declared the extend with annotation on the test method here, right? But it allows us to have some additional values that we want to pass to the extension. Okay, so in this case, we have a local implementation of an extension here, which implements the execution condition interface, which is one of those extension point interfaces that you can implement. And it extends extension, which is just a marker interface, nothing fancy here. So execution condition has a single method, and most of these interfaces do actually only have one method. It takes an extension context evaluates the execution condition, so basically itself, and returns a result. The result is basically, is this test to be enabled or disabled, and for which reason? So it's a string in addition to a Boolean, basically. The extension context, that's a bit more interesting. The extension context represents the node in the test tree. So for example, if this extension acts on a test method, then at some point it will get the extension context that represents this test method, and it can, for example, get the test method object from there, or its display name, or the tags that are attached to that test, and its unique ID, all kinds of things. So you can use that to reason about what am I about to execute. Okay, let's look at the example and it will become more clear. So let's collapse that for now. Okay, so this is the implementation, the method. First of all, we check, okay, is this test method even there? Is this really an extension context for a method? Because our annotation only supports methods. If it's not a method, we just continue, say enabled, and then JUnit will just run it. If it's a test method, then we're going to get the environment system property that we've seen in the launch config. And if that's null, we're going to disable the test just to be on the safe side. Maybe someone forgot to actually pass that system property. And yeah, so we rather disable it to be safe. Otherwise, we have an active environment, system property is set, we are on a test method, then we can get the enabled environments from the test method. And then in the end, we can check that the active environment is actually enabled, right? That it's contained in the enabled environments. If so, we return this enabled condition evaluation result with the reason, otherwise we return disabled. And the interesting part, of course, also is how to get these enabled environments. Pretty simple. We have a method, and we can find the enable for environment annotation. We're using a support class that JUnit provides to extension authors, which is annotation support. To find that annotation, if it's present, we get its value, we map it to set, and that's basically a set of strings that we have. Otherwise, if it's not there, I'm just going to use the empty set. So that's a way to have a custom condition that you can implement in any way you want to reason about the test and whether it should run or it should be skipped. Okay, so that's pretty nice. And actually, all the JUnit has a disabled annotation in its core. It's implemented the same way. It's just a very simple implementation that checks for certain annotation and just disables all the tests that have it. But what if I actually want the behavior to be like this down here? If I remove this comment, this is actually the behavior that I want maybe by default. I want all the test methods to be checked whether they declare this environment and be executed. And as you know, it's quite easy to forget sometimes putting some annotation at some place, right? So someone might forget that, and that would be bad, because then this test might run against production. We don't want that maybe, and then, yeah, all kinds of nasty things could happen. So in order to solve that problem, we can use global extension registration. For that purpose, JUnit provides a property that you can set. So there's different ways to set these properties. You can use system properties. You can use this JUnit platform properties file that lives in your class path. Basically, that's the easy way to do it. Then it gets automatically picked up. You don't need to set system properties all the time. There's also an API to set them. But yeah, for now, I'm just going to see that this property here, auto detection enabled, that actually is the property you have to set to true to activate a global extension registration. It's an opt-in feature, because we at least feel there should be some hint that this is activated and the test gets influenced by some extensions that come out of nowhere, right? So it's magic, but use it wisely. And that's why this switch enables the magic. And in order to actually pick up the extension, you need to use the service loader API, as I mentioned. And that works that you have a meta-inf services directory in the resources, And in there, you have a file that has the name of the interface that you implement. In this case, it's just the extension interface. That's what we look for. And in this file, you list all the extensions that should be available using Service Loader. In our case, it's just our little execution condition, right? So if we do this and we go back to our test, there we are. Now, if you run this again, you will see that subtract is now disabled. Oh, I should actually remove this again, sorry. Right, even though the annotation is not present, and that's because the extension is now registered globally for all tests. So we could actually now remove this extend with from here. But we can also leave it. I mean, it's not going to be a problem. Okay. Sometimes it's useful, though, to temporarily disable those conditions. Say you want to run all the tests and don't care about these restrictions that we have imposed on ourselves by implementing these execution conditions. You can set a different property, JUnit Jupyter conditions deactivate. You can set it to a pattern for a fully qualified class name. In this case, it's just like all conditions should be disabled, or deactivated, I should say. And in this case, when I run this again and have set this property, all the tests will run. So there's multiple ways to influence that. And you can really, do a lot with these conditions, and it's really useful for integration testing. All right. So let's revisit some of the concepts that we've seen. First of all, we had seen the extension context, which represents the current node in a test tree. So we can get meta information about the node. So it could be a test class or a test method. It has a name. It has tags, it has some other information. So that's kind of what you can use. We provide all the information that JUnit has to the extension author. It's actually a tree. So if you have one of these extension contexts, you can get the parent. So you could actually look at the whole test tree by that from the node up. So at least the path to the root. And for example, if you are at the test method at the lower left, you can get the extension context for the parent, which is the test class, and you could check the test class for having some attribute or something. That's also perfectly possible. Yeah, so that's the first example I wanted to show you today is how can you use custom logic to determine whether a test class or method should be skipped, and how to register those extensions globally without actually changing code, and you can also deactivate a condition without changing the code using a configuration parameter in this properties file. All right. So the next sample I'm going to show you is how can I put my test setup and tear down my test fixture into a separate extension that I can reuse. You might reuse that within a project or across projects. That's both possible. Okay. So the second example is a bit more complicated. First of all, I'm going to revert this, otherwise all the tests would not run or so. So here we are. Okay, so this class is called container test. Container tests, I should say. Okay, now we have one test in this class. It's called insert into table. It has a test annotation on it, but it also has a custom annotation that I invented for the sake of this example. It's called container. It specifies an image, which is a Docker image, and a port mapping. So in this case, we're just going to start up a database, basically, a local MariaDB. So we set the MySQL port binding and the root password and the database that should be used, and basically declaratively say we need this container for this test. And we want an extension to be responsible for spinning up the container and stopping it in the end. And in the test, that's not all that interesting. Basically what we do, we then connect to the database, we create some example table, and we insert some data. This would normally be in your production code, not in the test, of course, like the logic how to insert it. And then we get the names from the table and we check that, the names we just inserted up here come back out. It's basically the test. But that's not the main focus for today. So it's really about writing this extension. And so I'm going to show you. Let's see. Oh, where are we? OK, so right now I don't have any Docker containers running, right? So I'm going to run this test in debug mode, so actually believe me that this does something. All right, here we are. And if I go to the terminal now again, you can see that there is now a MariaDB or whatever, however you pronounce that, container running. And it started 7 seconds ago, so that was us. And if we go back to debug and let it run, we will see that the test continues and fails. What did I do? Oh, I typed. OK. Now let's do it again. Don't worry about this exception stuff here. That's from the Docker client library I'm using and running this on Java 10. So I know some of you have been there. So the test is green. Going back to the terminal, you can see that the Docker container is gone again. So how does this work? Well, same pattern, basically. We have a local annotation named container, and it has a meta annotation Docker extension, which is the local extension that I've implemented here. So this might not be totally production ready, but it works for this use case, and it's really simple. So we have implemented 2 extension interfaces before each callback and after each callback, and I'm going to look at them one by one. So before each, what each does is basically get the annotated element. So this is the test method or the test class, and look for the container annotation. If it's present, it's going to start the container. And I'm not going into any details how this is done. It's just using the Docker client Java library. It gets the values it should use from the annotation, like the image, the environment variables, the ports. And if it has done that, it's going to store the container ID. Why is it storing it? Well, in the after each method, it needs to get the container ID again to actually be able to stop the correct container after this test has run. So after each is called after the test execution, gets the container ID, and if there was a container started even, it stops the container again. So that's the basic logic, how this works. And you might wonder what this get store thingy is. And yeah, well, I can show you that. It's basically something that the extension context provides to extension authors to put values in and read them from there, of course, again. Because, yeah, it's really hard to get this right as an extension author, because the extension is only ever instantiated once and used for all kinds of tests. And we will soon introduce parallel execution, and then it will just be really tough for each extension author to make it his or her extension thread safe. And yeah, so that's why the store abstraction is really useful. So yeah, I'll reset that. So basically, you often need to store some data to clean it up later. And it would be really error-prone to kind of have every extension author do this job by himself. So we provide this abstraction, and it's basically a map-like interface. So you can put values in and you get values, but it's namespaced. So you can use this namespace, there's even a global namespace, to make sure that this data is only for your extension. Then you would create a specific namespace for your extension. Or you could use this namespace to share data between extensions. That's also possible. So for example, if you store something in a global namespace, some other extension could also access it from that global namespace. And also important is reading from the store. If you don't find something on the method level, for example, it will continue to look up on the class level and get the value from there if it's present. So if you like pictures, this is basically how it looks. You have an extension context for the test, the lower left. And given a namespace, you can get a store. But you could also go to the parent of this extension context and, given a namespace, get a different store, right? So that's all perfectly possible. You can store stuff on the test class from a test method, callback, and that all works. Why would you do that? You get automatic cleanup. I just mentioned you get thread safety. You also get this. So you can, since 5.1, you can put a closable resource as an interface that we provide into a store, and it will automatically get closed when the store is closed. So basically, when we clean up, so when the test execution is finished, we will clean up the store of the corresponding extension context and close all those resources, which makes it really convenient to put something in there without worrying about the cleanup. So this is an example I actually used in the code base. I have not shown. So this is the Docker client, is basically the connection to the Docker daemon. And I only need to create this once and can reuse it for all the tests. So this is how it's done. I just implemented a closable resource and put this into the root store of the root extension context. And then all the other times the extension gets called, it just can get the Docker client from there. So you don't have to reinstantiate it every time or reconnect to the daemon every time. All right. So in this example, we have seen how to use the store class for extension state, how to use lifecycle callbacks like before each and after each callback to enable reuse of this test fixture. And we have seen how that we can implement actually multiple extension interfaces in a single extension. All right. The next example is about resolving test parameters. So this builds upon the other example that I've shown you. So I'm still going to use the container annotation that we've seen here. But I'm going to register an additional extension, which is a parameter resolver. So this is just a regular test. It does have the test annotation on it, but it has parameters, which, if you only know JUnit 4, looks kind of strange. Where do these come from? So in JUnit Jupyter now, test methods can also have parameters. And you can implement extensions to resolve those. And the test reporter is actually something that is built into JUnit. It also is a parameter resolver, and you can use this test reporter to publish additional data that should be attached to this test. So instead of printing something to system out, you can really use some API to attach it to the test. And eventually there will be a new reporting format that the tools support that will actually show that attached to the test node. So you don't have to search through the system output, which gets especially messy if you use parallel execution. Okay, that's from JUnit, but the network settings here, that's a class that comes from the Docker client library. That is something that the Docker parameter resolver that I have here actually resolves. Maybe 2 steps back. Why does it do that? In the previous test I've shown you, we always use the same port binding. So we have a binding from the MySQL port, the standard one, to the standard MySQL port. That works fine unless you have another MySQL running. Or if you use parallel execution, run multiple tests at the same time, you will get conflicts because you can only spin up a Docker container with that port binding if it's not already taken. So what we want to use is Docker's dynamic port binding. And we just want to say, okay, I need this MySQL port. Please, Docker, give me some port for this. And then in the test, however, you need the port to connect to the database, right? So this is what the Docker parameter resolver that I've written here does. Okay. So the parameter resolver interface has 2 methods. The first one, supports parameter, is called by JUnit to determine whether this extension, this parameter resolver, can actually resolve the parameter. So you need to return true if you want to resolve it. In our case, we're just going to check, is there any container ID for the current extension context? So did we actually start a container? And if so, going to check if the parameter of the test method that we are about to resolve is actually of the expected type, namely network settings. If so if we return true from here, JUnit will also call the resolve parameter method, and we get the same two arguments here. So we can get the Docker client, that's the one I just shown you, the closable resource, and we can get the container ID, and then we're just gonna call inspect container and get back the network settings. And that's what we're gonna return. And all the rest, injecting that into the test method, that's done by JUnit. Okay, so let me run that at least once. Yeah, you can see down here, what IntelliJ currently does is, show these repo entries that we have, so this publish entry here in the console view, even though it's not actually printed to system out. So this was the port that was used by Docker automatically. If I start this again, it's likely that it will change to a different port. Yeah, it just increments by 1 basically until it has to start over again. So that does work. All right. So you can use this in whichever way you like. One way to do it, to use this for, is to provide some information back from the extension to the test method, like in this case. You can also use this for test class constructors, for before each or after each methods. It's not just for test methods. Okay, next up is actual parameterized tests, not just tests with parameters. All right. So let's get this stuff out of the way. All right. So I have a class here, parameterized tests, and it has a couple different parameterized tests. The first one uses the parameterized test annotation. That's the main difference between those kinds of tests. And if you use this annotation, you somehow have to provide JUnit with the source of arguments. So it has to know from some source they have to come, and in this case we use the simplest one, which is called value source, and just say, okay, I have these 2 strings here, use those as arguments. And if I run that, I'm gonna see, okay, I have foo bar as just my 2 arguments that I have here, right? So the next one is a bit more complicated. I have CSV source. I again provide 2 strings, but as you can see, these are comma-separated values, so each string will actually become 2 arguments for 1 invocation of this parameterized test, right? And you can also customize the name here. So as we will see down here, you can have foo 242, bar 223, and that's your parameterized test. And this is all built-in features of the parameterized test infrastructure. If it's a bit more complicated, for example, if you want to use your own domain object, like a person in this example, you can, for example, use method source. And method source, well, we reference a method using a string. And in this method, you can return a stream or an iterable of person in this case. And yeah, we're just going to create 2 person objects and return them. And that's going to work in the same way. Basically, we have 2 invocations of this parameterized test now, and both use a different person object, right? All right. So far, that's all been features that are built into JUnit. Nothing to do with any extension or anything. But actually, they are implemented as extensions. And you can do the same thing to implement your own source of arguments. So I have down here another parameterized test, which has the JSON source annotation. So I want to read some data from some JSON file and use that to create person objects. And this annotation is not part of JUnit. So this is what the JSON file looks like, basically 2 person objects. If I go back here, I can run this test, of course. The body is not that important. And as you can see, we have, again, two-person objects. It's kind of the same as the method one. I mean, I can change the data, and you can see that it's actually going to be picked up. Well, now it's red because it should not be buzz, but it was buzz, so it was going to change it back. So this is how you could use it. So in the next step, let's look at the implementation. So JSON source is another local annotation that I have here. It has argument source annotation on it and provides the class literal for the implementation of this arguments provider, which in our case reads JSON. So basically you have to implement one method for arguments provider, which is provide arguments. And there's a utility interface annotation consumer that has this accept method. Since most of these sources are annotation based, you can use that and JUnit will automatically inject this annotation from the test method to your provider. In our case, we're going to use only the value of the annotation. That's going to be our JSON resource. And we're going to check at the extension context, again, extension context, and get the parameter type from there, because we have to pass that to the JSON parsing library that we use, which in this case is Jackson. So I'm going to use an object mapper, create a reader for the parameter type, and read the values. There's an iterator. I will just convert that into a stream and basically return that from the provide arguments method. So this arguments interface here is really simple. It has a get method for an object array. So basically it's encapsulating an object array. So that's all you have to do to implement your own source. This could be anything. This could read from the database, or I don't know. The only limit is your imagination, really. All right, so we've seen all that. And that's really powerful, and all the sources that JUnit provides are implemented the same way. So there's no special API that JUnit uses that you cannot use. It's just all extensible, and yeah, you can extend it. Last but not least, we have test templates. So a regular test usually is a method that is executed once. A test template is something that is executed multiple times in different contexts. So think about a parameterized test. Basically, it looks like a method definition, but it has a different annotation on it. And actually, it's implemented internally as a test template in JUnit. And you can also use the same mechanism for yourself if you want. And now this is really getting more advanced to implement your own kind of, context provider that tells JUnit how to, or how often, and with which contexts to invoke this test method. Alrighty, so let's see. I have written my own poor man's little property-based testing thing here. Yeah, as I said, this is not production ready, but basically this is not a test, but it's a property. So I don't know if you're familiar with property-based testing. Basically, in regular unit tests, you usually write example-based tests. So you have some given input and you have some expected output, and you check that those two kind of match after you've called your production code. And the property-based testing is a bit different. You specify more general properties or invariants or whatever you might call them that your test should uphold. No, not your test, that your production code should uphold. In this case, I'm just going to use list as an example. So for example, we have a property here that says when an element is added to a list, the list size should increase, right? That sounds easy enough. So for this property, I need a list of strings, and I need a string new item. And I'm going to get the previous size, so the current size right now. I'm going to add the new item, and then I'm going to assert that the previous size plus 1 is my new size. So let's run this. Okay, so you've seen we've just executed 100 tests, not one, because we have an extension registered that gave JUnit 100 test invocation contexts in which this was executed. So these look kind of cryptic. That's because of this example. I'm just creating a random list of strings using UUID. So these are all kind of strings, but rather long ones. And yeah, that's why it looks so a bit cryptic down here. I have another property here. Removing an element decreases list size. Sounds easy enough, right? Let's run that. It's red, okay. Okay, it stopped after 3 attempts. And apparently it found a counterexample, the empty list. Okay, obviously the empty list, I cannot get the first element from the empty list, so it's not gonna work. What can I do? Well, I'm just gonna say assume false. So assumptions are still a thing in Jupyter. There's an assumptions class. And in this case, I'm just gonna say items is empty. And what this will do is it will just ignore those cases where the list is empty. So we have now passed 81 tests and ignored those 19 where the empty list was generated. So this is not really meant to be a property-based testing framework on its own. It just serves as an example. There are good ones. So if you want to use this, there's actually a test engine that works on a JUnit platform. It's called JQuick that provides nice property-based testing support, including shrinking and everything. But this one is just really simple. It is a custom annotation again, and this time it's annotated with 2 Jupyter annotations, extend with, my property invocation provider, and the test template annotation. So test template is used instead of test, basically. And the provider then is responsible for providing test template invocation context instances. So it's a test template invocation context provider, which is rather a long name. So let's see. Like the parameter resolver, it has 2 methods that you need to implement, a supports method and a provide method. The supports method checks whether this extension can actually work with this extension context or the element that it represents. In this case, we're just going to check if the property annotation is present on that element, and we'll assume, okay, looks like it's a property. This extension is responsible. And if so, JUnit will call the provide test template invocation contexts method. And in this example, well, yeah, I have to look up the annotation somehow because I need to get some values from it. So it has an invocations parameter. I haven't shown that, but by default, we've seen it runs 100 invocations. You can also customize that. It also has a random seed annotation. So in case you want to repeat the same invocation, giving the same random numbers again, you can also do that. And basically, in the end, what it has to do is it has to return a stream of test template invocation contexts. And what a test template invocation context is another interface. It has 2 methods. You can have a custom display name per invocation. So what we used was this rather long toString of the arrays. So it printed the list and it printed the other argument. But more interesting is you can register additional extensions for this one invocation of the test template. And in our case, we're just going to register an additional parameter resolver, which injects the random arguments that we've just generated. And after each callback, which basically checks that if the test if the test failed, we should not continue. We're just going to stop after the first failed test. Yeah, so basically that's how it works on the big picture. Again, there's lots of details. If you're interested in that, please check out the code on GitHub. So we have learned that you can execute a test multiple times using different contexts, and how you can do that using a test invocation context provider. This is by far the most complicated extension point, really. The other ones are really pretty simple. I mean, parameter resolver has 2 methods, but the other ones only have 1 method, and they're easy to grasp. All right, support classes. So the JUnit provides some support to extension authors. There's an annotation support class, which we've seen a couple times, that you can use to scan for custom annotations. It provides the same support for composed annotations as is used in the Jupyter engine. So you can also use meta annotations with your own annotations, that works, and compose them. And there's also reflection support in case you need to do class path scanning or call a method using reflection. We provide some support for that. That makes it easier to do. Okay, summing up. We've seen some of the extension points, those with a check mark. There is more. And the thing is, this might not be the whole list that we have a year from now, so we might add some. If we find out that we have that there's a use case that we haven't covered that well, we will think about adding an extension point, of course. So if you find out that something is missing, please let us know. We're happy to discuss it with you. And the bottom line here is it's really, really extensible. So Jupyter is designed to be extensible. That was one of our main goals. There are a lot of extension points to choose from. We will add more, and the power really comes from combining these extension points and do really nice things and make your testing much, much more flexible. There are already lots of third-party extensions. So there's an official extension for Spring, for Mockito. There are some other implementations for Docker and ViaMock and stuff like that. We collect those on a wiki page that's free to edit. So please, if you find some additional extension or even write and publish some, please put it on that wiki page. And this is really picking up right now, so I'm really happy to see that. As far as you guys getting started, there's a really good user guide, I think, that provides details on each of these extension points. There's sample projects, not only to get you started using a build tool like Gradle, Maven, or Arndt. There's also a project that collects some extensions and shows you how the setup that you need, which really isn't a lot, but there's still a sample project for it that you can check out. Of course, there's JavaDoc that explains a lot more detail than I was able to do today in this talk. All right, what we want as a JUnit team is we want your feedback. So if you have a question, please head over to Stack Overflow, open a question. We monitor the JUnit 5 tag really closely, so in case there's a question that's not answered, we will do that. The JUnit team will answer. Of course, you can also create an issue in case you think or you suspect this is a bug or maybe a missing feature. We would love to hear from about that from you. And so please go to GitHub, check out the code, open an issue. If all that's too much, we also have a Twitter account, so you can also ping us there. And we will respond usually within a couple days, I think. Yeah. So really try this out and let us know. I mean, this is really an open source project. We do this in our spare time, basically. So we would at least love to hear feedback from you guys and let us know, please. All right, so the example code, as I've shown multiple times, is on GitHub. So that's the link again. Now we have 2 minutes left for questions. Are there any questions? No questions, really? Don't be shy. There's one.
Can you control the order if you have multiple extensions registered? Can you control in which order they do execute?
So right now they are executed in the order they are registered in. So if you can control that at least, then you can have some control about it. We will introduce a mechanism to rearrange the order at some point. Haven't done that yet. Okay, any other question? If not, I will be around maybe half an hour or so. I'll have to catch my plane then, but please feel free to contact me. I'm also on Twitter, and the JUnit team is as well. So if you happen to think about a question later, then please let us know. All right, then thanks.